A block of mass 45 kilograms is placed on a horizontal table. There is no friction between the block and the table. An object of mass 15 kilograms is placed on the top of the block. A force F acts on the block so that it accelerates. The acceleration of the object and acceleration of the block are the same, so that they do not move relative to each other. The coefficient of static friction between the block and the object is 0.6. A states the nature and direction of the force that accelerates the 15 kilogram object. So let's consider this upper 15 kilogram object and what forces are acting on this object. Definitely it's mg, normal reaction, and since a block and the object are in contact, there is the frictional force, but the question is what is direction of this force, and since there is no relative motion, it will be the static friction, not dynamic. And if we consider the second Newton's law, it says that the vector sum of all forces is equal to ma vector, and if we consider it in horizontal components or in projection of horizontal axis, components of n and mg are zeros, so there is only one force in horizontal direction. It's the frictional force, and it will be the net of the resultant force. And since they are moving to the right, so acceleration is to the right, so the resultant and it's the only frictional force also must be to the right. It's frictional force applied to the upper object. Notice that this force is not applied to the upper to this object, and it cannot be taken, or it must not be taken into consideration, because if you consider Newton's second law with respect to this object, there must be forces which are applied to a given object only, not forces which are applied to other objects. So, nature and direction of the force which accelerates the 15 kilogram object. So, it's a static friction between a block and the object and directed to the right. B. Determine the largest magnitude of F for which the block and the object do not move relative to each other. So, second Newton's law with respect to the upper object and in horizontal projection. So, it's frictional force, components of n and mg are zeros, and it is equal to ma or 15a. But we know for static friction that frictional force is less or equal than mu, static normal multiplied by normal reaction. And if we consider second Newton's law in vertical projection, you can see that it just n is balanced by mg, so it's clear that n is mg, so it becomes mu static mg, and we can calculate it, and it becomes 0.6 times 15 times 9.8, and it becomes 88.2 newtons. You may consider just maximum possible value for the frictional force instead of using inequality sign. And F is equal, and it must be less than 88.2. Or we can find the maximum possible acceleration if required. And now let's consider the block. What forces are applied to the block? It's F, and again we consider the second Newton's law in horizontal components, and forces are the next. It's F, and there will be also the frictional force which is applied to the lower block, but it will be in this direction, because this friction and this frictional force are action-reaction pair so that these vectors are of the same magnitude but in opposite directions. So it will be minus F frictional. Components of Mg and normal reaction also are zeros, and there may be some additional force from 15 kilogram object, but also its component is zero, and this is equal to 45A. It's just the second Newton's law. And we need F, so F becomes F frictional plus 45A, and from this we can substitute for A, so A is what? F frictional over 15, and it becomes is equal to F frictional plus 45 F frictional over 15, and you can see it's 3 plus 1, it becomes 4 F frictional, but F frictional is less than this, so it becomes less or equal than 4 times 88.2, and you can see F becomes less or equal, so F maximum, or F is less or equal than 350 to two significant figures newtons. Or you may consider these two blocks as one object, and this frictional and this frictional cancel each other because it's action-reaction pair, two equal forces in opposite directions, and they are called inner forcers, and they just cancel each other, and hence we can see that mass of this object becomes 60 kilograms, and there is only one force which accelerates it, it's F, so we can write that F is 60A, and we can substitute A from this, or you may just substitute maximum possible acceleration to get maximum possible force, or it becomes 16 frictional over sorry, not 16, 60 frictional over 50, and you can see 4F frictional, and F frictional is less static friction is less or equal than what, 88.2, so it's 4 times 88.4 and 0.2, sorry, and you get absolutely the same result. And you may use just this value as maximum possible frictional force or maximum possible value of acceleration to get the maximum possible force. So you may use just equality and equality, F equals and everything equals instead of an inequality sign. And that's all for this question.